Hey guys, welcome back. It's been a while. Today we are factoring polynomials. Hey guys, and welcome back. This is Franck. If you like this video, don't forget to give it a thumbs up and share it with your friends. That would really help me. And if you haven't done so already, go ahead and subscribe to my channel so that you don't miss any future videos. So last time we talked about polynomials, and this time we're going to be working on factoring polynomials. So I'm going to give you some techniques that you can use to factor polynomials. We're going to talk about the greatest common factor. We're going to talk about grouping, and then I'm going to give you some formulas that you can use when you see some polynomials that are recognizable. To factor an algebraic expression means to rewrite it as a multiplication of factors. And before I give you some examples on that, let me talk about something that feels a little bit more natural, which is expanding. So let's see this example here. So if I give you an example that's already factored, 10x multiplied by 2x squared minus 3, and I ask you to expand it, then what you would have to do is multiply every term on the first factor, 10x, by every term on the second factor, 2x squared minus 3. So since the first factor here only has one term and the second factor has two terms, we're going to multiply this one term by the two other terms. So we're going to have 10x times 2x squared. That's going to give us 20x cubed. And then we're going to have 10x times negative 3. That's going to give us negative 30x. So this is what is called expanding. And so factoring is going to be going backwards. So you're going to go from this particular expression here that has terms to the other expression that has factors in them. And so let me work on this example again and try to go backwards and explain to you how I do it. If you take this example out here, you're going to have 20x cubed minus 30x. So what you have to be able to do is pull out the greatest common factors from all of these terms. The first thing I would do is look at the numbers of these terms. And if I look at 20 and 30, it's very apparent that the factor that they have in common is 10 because 20 is 2 times 10 and 30 is just 3 times 10. So 10 is the common factor. Also, they share the variable x, so x is a common factor as well. So I know that these two terms have 10x as a common factor. And so I'm going to have 20x cubed written as 2x squared times 10x. And I'm going to have negative 30x written as negative 3 times 10x. Since I see that 10x fits on both of those terms, I can put it out as a common factor. And so I'm going to have 10x on the side. And in the parentheses, I'm just going to put whatever is left after I take the 10x out. That means 2x squared minus 3. Right? So this is what factoring means. Factoring means to go backward. And it requires a little bit of trial and error sometimes because I consider this to be an art form. There's no one method fits all. You have to really do a lot of these to get a feel of it and know what you have to do when you see an expression and you need to factor it. Let's look at the next one here and still use the method and still use the greatest common factor method. So if I give you 18xy here plus 27y, and I ask you to factor it, again, I'm going to look at the numbers first and say, okay, what common factor here do I have here for the numbers? I have 18 and 27, and I can see that 9 is common to both of those numbers. So if you do 18, 18 is 2 times 9, and if you do 27, 27 is 3 times 9. And so you also can see that y is common to also both those terms. And so you can say, oh, 9y is a common factor for both those terms. So you can rewrite those terms as 18xy is going to be 9y times 2x. And then 27y is going to be 9y times 3. And so knowing that 9y is common to both of these guys, you can pull it out and rewrite this as 9y. And in the big parentheses, you're going to put everything that's left. That means 2x plus 3. The next example here is going to be something that you cannot use the greatest common factor for, at least at the beginning, because there's no common factor for it. It's going to be x cubed minus 2x squared plus 5x minus 10. As you can see here, if you look at the numbers, there's no greatest common factor for all those numbers, except for 1, which is useless. And the x variable is not sitting on all of the terms, so you cannot factor x either. This is going to be common with polynomials that have degrees 3, 4, and so on and so forth. Degrees that are bigger than 2. Those guys here, you most of the time going to have to group the term together and try to figure out if you can come up with partial factorization and then move on from there. So I'm going to group those terms together. The two first one, I'm going to group them together. That's going to be x cubed minus 2x squared. And then the two next one, 5x minus 10, I'm going to group them together. And so starting with the first grouping here, I'm going to notice that x squared is a common factor to both of them. And so if I take x squared from x cubed, I'm going to be left with x there. And if I take x squared from negative 2x squared, I'm going to be left with negative 2. So I can write this first group as x squared. And in the big parentheses, I can put x and negative 2 in. For the next grouping, I'm going to realize that 5 is a common factor to 5x and 10 because 10 can be written as 2 times 5. And so I'm going to have here 5, and in the big parenthesis, I'm going to put x minus 2. So this is just partial factoring, and you can see here that right away, you notice that now we have two terms. And in those two terms, you have a common factor of x minus 2. And so you can pull out the x minus 2 here, and then put whatever is left in the big parenthesis. So that's going to be x squared plus 5. And so you're done, right? So if the greatest common factor doesn't work, go ahead and try grouping them, and then try to do a partial factorization. Try the greatest common factor again, and that might work. On the example that I just gave you, you have to be really creative on how you work on these things because there's no one method fits all. But for the few next example, there's going to be actually formulas that are written for them. So you don't have to work that hard. You just have to know what formula to use and then apply it. So the first method that I'm going to give you here is the difference of squared. So if you're ever working on factoring polynomials and you find yourself with something that looks like something squared minus something else squared, right? So the difference of squared. So in this case, imagine you have a squared minus b squared. So this could factor and give you a minus b altogether multiplied by a plus b. So this is our first formula. This is called the difference of squared. And so if you wanted to check if this works, you can go ahead and just expand this expression again. And so you're going to have a times a, which is going to give you a squared, and then a times b, and then negative b times a, and then negative b times b, which is going to give you negative b squared. And as you can see here, the middle terms here are going to cancel, and what you're going to have back is a squared minus b squared. So this works out, right? So this is formula you can use whenever you find an expression that is written as a difference of squared. You can just factor it directly like this without having to think about what method is going to work here, because this is the method that's going to work. The next one is going to be the differences of cube. If you find something that looks like a cube minus b cube, then you should know that your answer should just be a minus b altogether multiplied by a squared plus ab plus b squared. And the last one is going to be the sum of cubes. So if you have a cube plus b cube, then you know your answer should be a plus b altogether multiplied by a squared minus ab plus b squared. So there's a couple of things I want you to notice from these three formulas. First of all, there's no formula for the sum of squared. So if you ever working in factoring polynomials and you find yourself with a sum of squared, then there's no formula for that. You can't actually do anything with that polynomial. You have to leave it the way it is. There's no way to factor it. And the second thing I want you to notice from these formula is that if you are trying to memorize them, you should notice one thing that's going to be very helpful to you is that the sign always to the same, then it changes, and then after that it's always positive. And so you can see here in this example for the difference and sum of cubes, the sign is always going to be the same, and then it's going to change, and then it's going to stay positive. So plus, plus, negative, plus, minus, minus, plus, plus. So same, different, always positive. Same, different, always positive. Let's look at some examples here as well. So our first example here is going to be x squared minus 100. So right away, right, you can see, oh, this guy right here is x squared, and 100 can be written as 10 squared. So you can see, oh, this is actually a difference of squared. So if I want to factor it, I don't have to think too much. I just need to use my formula here, and a is going to be x, and b is going to be 10. And so I'm going to have x minus 10 altogether multiplied by x plus 10. And then this is going to be done with the factorization. And so if I give you another example here, just to make this sink in, 36x squared minus 49. Again, realize that the 36 here is the same thing as 6 squared. So if you merge this thing together, it's going to be the same thing as 6x altogether squared minus 7 squared, because that's 49. And then again, this is a squared minus b squared, where a is 6x and b is 7. And so you're going to have 6x minus 7 altogether multiplied by 6x plus 7. Last example here in this category, let's say I give you x to the power 4 minus 16. Again, realizing that this x to the power 4 is the same thing as x squared squared. And the 16 here is the same thing as 4 squared. So this is again a difference of squared, where a is going to be x squared and b is going to be 4. So in this case, you're going to have x squared minus 4 altogether multiplied by x squared plus 4. Now, right here, you can notice something is that the first factor in this factorization, x squared minus 4, is again a difference of squared. So you can actually go on and simplify it further. And so you could have x as a here, and then 2 as b, because 4 is 2 squared. So that will give you x minus 2 altogether multiplied by x plus 2 altogether multiplied by x squared plus 4. And then you can stop here, because remember, there's no formulas for the sum of squared, only the difference of squared. Let's move on from this category and then go to the next one a little bit. And so let's say I give you an example like x cubed minus 64. What you notice here is that 64 is the same thing as 4 cubed. So this is going to be a difference of cube. And if you remember the formula, it goes same, different, always positive. And so this is going to be a is x and 4 is b. So you're going to have same, x minus 4, and then x squared plus 4x plus 4 squared, right? Same, different, always positive. And then the next one is going to be x cubed plus 27. And so for this particular one here, you should notice that 27 is the same thing as 3 cubed. And so this is the sum of cube. And so you're going to have x as a and 3 as b. And so you're going to have x plus 3 altogether multiplied by x squared minus 3x plus 3 squared. Same, different, always positive. All right, guys, that is it for now. The link for this note is always going to be in the description below. If you like this video, don't forget to share, like, and subscribe. Also, follow me on my other social platforms on Facebook, Instagram, Snapchat, and Twitter at Franck's Note, and I will see you in the next video.